Now, we did an investigation in class about reading graphs, making our tables, and finding out what happens when we combine them. For this one, we're going to look at what happens when we take f of x, this line, and multiply it with g of x, this line. Now, if I made tables of those values and multiplied the y values together of each line, I would notice that anytime either one of these lines is 0, then my resulting product would be 0. Because, for example, here the y value is 0. The y value of this one is 4. 4 times 0 is going to give me 0. So I know one point of my new graph. Over here, the y value for when x is 6, f of x is 4, and g of x is 0. 4 times 0, again, gives me 0. What ends up happening is your x-intercepts of a polynomial split up the graph into what I call intervals, sections. The first break is at 2. The next one is at 6. Those are my x-intercepts of my new polynomial. The interval to the left of that would be the interval from negative infinity to 2. Between 2 and 6 is 2 to 6. And after that would be 6 to positive infinity. What we're going to do is think about what is happening to our signs in each interval. So using the graph, when I look at the interval between negative infinity and 2, if I picked, let's just say I picked negative 1 for my x value, and I was making a table, f of x would have a y value of negative 3. It's a negative number down here. Up here, the y value would be positive. So I think about what would happen on that table if I had a negative y value and a positive y value, and I multiplied them together. Well, my result, when you multiply negative times a positive, is going to give me a negative answer, which would mean I would actually have a y value somewhere down here. For example, here is a positive 5 times a negative 1 would give me a negative 5 for my resulting y value. Now, in between 2 and 6, let's look, for example, right here. When x is 3, f of x is 1, which is positive, g of x is 3. What happens when I multiply 1 times 3? I'm going to get 3. Here I have 2 times 2, which is going to give me 4, and so forth. Positive and a positive. Both of the y values are positive. And in the first section, one of them was negative and one of them was positive. So negative times a positive gave me a negative. Between 2 and 6, no matter which x value I pick, the y values are going to be positive and positive. A positive times a positive gives me a positive. After 6, f of x, every single one of its y values is positive, and g of x are all negatives. So after 6, I would be taking a positive times a negative. Positive times a negative gives me a negative. The resulting graph would have y values down here, and then if we noticed it went up, x-intercept's going to be here, and then it's going to go back down. So a rough sketch, it's going to do something like this. Now, we're going to try doing the same thing, but without the graph to assist us. So let's look at this first one. X minus 7 times 2x plus 5. Well, my x-intercepts, if I set each of those factors, let me see if I can get this a little bit less fuzzy. My x-intercepts are going to be 7 and negative 5 halves. I don't think that helps at all. Let's see. Don't know why the camera's so fuzzy today. Sorry about that. That's okay. You can see the writing. Negative 5 halves here and 7 here. The first interval is negative infinity to negative 5 halves. Then I have negative 5 halves to 7. Then I have 7 to infinity. What I'm going to do is in each of these intervals, choose an x value. And then I'm going to plug it into each of the parentheses. By doing that, I can check the signs of the resulting answers. So, something between negative infinity and negative 5 halves. Let's go with negative 10. If I plug in negative 10 minus 7 is going to be a negative answer. 2 times negative 10 plus 5 is still negative. Negative times a negative is going to give me a positive. Something between negative 5 halves and 7. Let's go with 0. 0 minus 7 is negative. 2 times 0 plus 5 is going to be a positive. And a negative times a positive is going to give me a negative answer. Something bigger than 7. Let's go with 10. 10 minus 7 is positive. 2 times 10 plus 5 is positive. A positive times a positive is going to be a positive. I'm going to have a parabola that opens up. Let's try another one. X plus 2 times x minus 3 times x plus 5. My x-intercepts are negative 2, 3, and negative 5. Now make sure when you're plotting these on a number line, you plot them in order, smallest to largest. That's going to help a lot. Each of these intervals, negative infinity to negative 5, negative 5 to negative 2, negative 2 to 3, and then 3 to infinity. I'm going to choose a number in each of those intervals and plug it into each set of parentheses. So something smaller than negative 5. Oh, negative 10 again. How about that? Negative 10 plus 2 is negative. Negative 10 minus 3 is negative. Negative 10 plus 5 is negative. Negative times a negative times a negative is a negative. Between negative 5 and negative 2, I have negative 4. Negative 4 plus 2 is negative. Negative 4 minus 3 is negative. But negative 4 plus 5 gives me a positive. So a negative times a negative, positive, times another positive, gives me positive. Between negative 2 and 3, I'm going to choose 0. 0 plus 2, positive. 0 minus 3 is negative. 0 plus 5 is positive. A positive times a positive gives me a negative. Something bigger than 3. Oh, 5. 5 plus 2 is positive. 5 minus 3 is positive. 5 plus 5 is positive. When I multiply 3 positives in a row, I get a positive answer. Every time I get a negative, my graph is below the x-axis. Positives are above. So it's going to go up, hit that x-intercept, go down, hit that x-intercept, and go up. And it keeps going up and keeps going on and on and on. The last one we'll do together. 6 minus x. The x-intercept for that is actually 6, because 6 minus 6 gives me 0. X plus 5. Negative 5 would give me 0. 3x minus 8. My other one is 8/3. When I plot those points, I get negative 5. Here's 8/3 and 6. The first interval is negative infinity to negative 5. The next one is negative 5 to 8/3. 8/3 to 6, and 6 to infinity. In each of these intervals, I need to plug in a point so that I can test my signs of my answers. So, in the first section, something smaller than negative 5. How about negative 10? 6 minus a negative 10. Here we have to be careful. A lot of people are making mistakes here. 6 minus a negative 10 is a positive number. Because when you subtract a negative, it's like adding. Negative 10 plus 5 is negative. 3 times negative 10, and then subtract 8, that's still really negative. Positive times a negative gives me a positive answer. Something between negative 5 and 8/3. Anytime you go from a negative to positive, you've passed up 0. So 6 minus 0 is positive. 0 plus 5 is positive. 3 times 0 minus 8 is going to give me a negative. Positive times a negative, I've got a negative. Something between 8/3 and 6. Let's go with 5. 6 minus 5, positive. 5 plus 5, positive. 3 times 5, 15, minus 8, that's positive. Positive times a positive is positive. Something bigger than 6. How about 8? 6 minus 8 is negative. 8 plus 5, positive. 3 times 8 minus 8 is still going to be positive. Negative times a positive is a negative. So this graph starts positive, goes down to negative, goes up to positive, and goes down to negative again. This is what is called sketching a polynomial using a number line model. We're not making an accurate graph. We're not plotting points. We're just getting an idea of what the graph is going to do, which is a very useful skill when you're not allowed to use a calculator.